Hi everyone, Mrs. Vara here, and we're going to look at examples, well, for sure 1 and 2 in this video. We'll see how long that takes. Maybe example 3 also. And this is section 2-1 on page 7 in your notes. So you should be following along in your notes and taking these notes that I am writing in the video and taking those notes in your note packet. And if I'm going fast or you're not following me, you can always pause and rewind the video. So first thing I want you to notice is that I had a little formatting issue here. So it wrote this 2 as a giant 2 instead of an exponent. So I just rewrote the function above it. It should be 3x squared minus 6x plus 7. And then the other thing you'll notice is these are a little bit different than your notes because we're going to find the axis of symmetry first, and then we're going to find the vertex. So it's a little different than your notes, but I think you can probably follow along what I'm doing. So the first thing we always want to do is find our A, B, and C. So in this example, A is 3, B is -6, and C is 7. So to find the axis of symmetry, I'm just substituting the B and the 2A into this formula. So first write the negative, that's part of the formula, and then our B is -6. All over 2, part of the formula, and our A, which is 3. So negative of -6 is +6. 2 times 3 is 6. 6 divided by 6 is 1. Whoops, not x. 6 divided by 6 is 1. So my axis of symmetry is x equals 1. And remember, axis of symmetry always has to be written as an equation, x equals. So now I'm going to go to our graph. I'm going to go over to x equals 1, and I'm going to draw my axis of symmetry, which is a vertical line at x equals 1. I'm going to draw that in right now. That's going to be the line that goes right down the middle of my parabola. Now I need to find my vertex. Well, remember, x equals 1 is the x portion of my vertex, and to find the y portion, I want to use my function. So in my function up here, wherever there's an x, I'm going to substitute in a 1. So I'm finding out what y equals when x equals 1. So my function is 3x squared. I'm going to write it as 3 instead of x, 1 squared, minus 6 instead of 6x, 6 times 1, and then plus 7. And this would give me 1 squared is 1. 1 times 3 is 3. So that would give me 3 minus 6 plus 7, which gives me 4. So if you're having trouble following that math, I recommend you pause the video and put that in your calculator and confirm that indeed it is 4. So my vertex, oh, I did it again. Keep writing x instead of 1. My vertex is 1, 4. And remember, vertex is always a coordinate point. Now I'm going to go ahead and graph my vertex. I'm going to go over 1 and up 1, 2, 3, 4. So there's my vertex. Oops. There's my vertex. Okay. Now I want to find, next thing on our list here is our y-intercept. Well, remember, y-intercept is always your c. And we said up on the top c equals 7. So our y-intercept is 7. That one's pretty easy. Direction of opening. For direction of opening, I need to look at my a value. And my a is 3, which is positive. So whenever I have a positive a, my parabola opens up like a smiley face. Positive people smile. So if A is positive, I open up. And if my parabola is opening up, then I know I have a minimum. Now what this value is asking is, where does that minimum occur? And it always occurs at the y value of your vertex, right? My vertex is my max and min, and when they ask for the value, that's the y portion. So my minimum value occurs at 4, because in my vertex, y equals 4. Okay, now I need to do a couple other points here to finish my graph. So I start with my vertex. My vertex is at 1, 4, right? Remember, we figured that out up there. And then I want to do 2 points to the right of it. So I want to do x equals 2 and x equals 3. So what I need to find out is, what does y equal when x equals 2? So I'm going to plug x equals 2 into my function. And I'm going to get y equals 3 times 2 squared minus 6 times 2 plus 7. And that equals 7. So that's 12 minus 12 plus 7. Yep, so that equals 7. Once again, if you're having trouble following this math, I know I'm going quick. Pause the video and check that in your calculator. And that should be a plus sign. Okay, now I want to look at when x equals 3, what does y equal? So that would be 3, this time, times 3 squared minus 6 times 3 plus 7. And that's going to give me 3 squared is 9. 9 times 3 is 27 minus 18 plus 7. That gives me 16. So when x is 3, y is 16. So now let's finish our graph. Let's plot these points. We already plotted 1, 4 right here. That's our vertex. Let's plot 2, 7. So over 2, up 4, 5, 6, 7. So there's a point at 2, 7. All right, so that's 2, 7. Now this 2, 7 is 1 to the right of our axis of symmetry. So then I know I'm going to have another point 1 to the left. Okay, now let's plot 3, 16. Well, I can already tell by looking at this I can go over 3, but 16 is going to be somewhere way up here. So I'm just going to put it right there. And I'm going to say that's 2 to the right of my axis of symmetry. So I want to go 2 to the left of my axis of symmetry. So this one didn't exactly fit on the grid, but that's okay. We have enough to get a pretty good idea that this is what our parabola is going to look like. So there, we did it. We found the axis of symmetry, the vertex, and we graphed our parabola. And I just wanted to go back and point out our y-intercept we said was going to be 7. And if you look here at that point right here, let me do it in blue so you can see, this point right here is at 7. So indeed, our y-intercept did end up to be on 7. Okay, so the next one is the same idea, but I'm going to fix this up here. This should be negative x to the second power, not this big old 2, plus 6x minus 4. So all the same steps. First thing we want to do is find our a, b, and c. So in this example, a is negative 1, b is 6, c is negative 4. Wow, that looks really bad. C equals negative 4. So to find the axis of symmetry, we're going to start with this formula, and we're going to do negative. That's part of the formula, and then we're going to put our 6, because b is 6, all over 2 times a. Our a is negative 1. So that gives me negative 6 over negative 2, which is a positive 3. So axis of symmetry, remember it has to be x equals, is x equals 3. So I am going to draw my axis of symmetry. I'm going to go over to x equals 3 and try to do as straight of a line as I can. There we go. So this is the line that's going to split my parabola right down the middle. Now I need to find the vertex. So the vertex has, there's my vertex. The vertex has the same x value, so x equals 3, and then I substitute that 3 into my function to find out what y equals when x equals 3. So I'm going to have negative 3 squared plus 6 times 3 minus 4, and that gives me, negative 3 squared is 9, plus 18 would be positive 9, minus 4 would be 5. So my vertex is 3, comma 5. And remember, the x in your axis of symmetry and the x in your vertex are always going to be the same. In this case, 3 and 3. So I'm going to plot our vertex. I'm going to go over 3 and up 1, 2, 3, 4, 5. So my vertex is going to be right there. Okay, y-intercept, our c equals negative 4. So that's our y-intercept. Our y-intercept is going to be negative 4. Direction of opening, I need to look at A. A is negative 1. So when A is negative, I always open down. I'm a sad face. And if I open down, then my vertex is a maximum, and the value of that will be 5. Right? So it's always going to be the x value of your vertex. Okay, so I'm putting a box around all my answers. Okay, now we're going to say this is the first point that we know for sure. That's 3, 5. That's our vertex. And I want to do 2 points to the right of it. And I'm just choosing those. 3 is the x value of our vertex, so I choose 4 and 5. And then I find out what y equals when x equals 4. So when x equals 4, y is going to be negative 4 to the second power plus 6 times 4 minus 4. And that gives me 4. So when x equals 4, y equals 4. And now when x equals 5, so I'm going to put a slash line here. When x equals 5, y is going to equal negative 5 to the second power plus 6 times 5 minus 4, and that actually gives me 1. So when x equals 5, y equals 1. So let's plot those points. Over 4, up 1, 2, 3, 4. So there we go. So this is downward facing, so it makes sense that this point should be below my vertex. This point is 1 to the right of my axis of symmetry, so I put 1 point to the left of it. And then the next point is 5, 1. So this point was 4, 4. And now let's plot over 5 up 1. That's that point, 5, 1. This is 2 to the right of the axis of symmetry. So if I can put another point at 2 to the left, and I can connect my points, and I've graphed my parabola. One of our learning objectives at the beginning was I can graph a parabola from 5 points, and that is what we did. And now let's just take a look at our y-intercept. We said it should be negative 4. 1, 2, 3, 4. So there's another point down there that we could use also, and that would extend my graph a little bit farther there. All right, I'm going to stop this video now, and I will do example 3 in a separate video.